Welcome back, guys. So as usual, we're going to go through another rundown of a Maths A paper. In this case, it's going to be the January 2018 or paper 4H, and this is the Edexcel International IGCSE. Anyway, without further ado, let's jump right in. So as usual, you got to know your formulas. So I've always explained this in every single paper, so I'll just go ahead and move on straight to the question this time. Okay, so here we have 22 questions. So hopefully this won't take more than an hour and a half or hour 15 or something. So let's have a look. Okay, so what does Mike do here? So Mike buys C pens and R rulers. Each pen costs 24 cents, whereas each ruler costs 37 cents. Mike decides to spend a total of T cents buying pens and rulers. So let's write down the formula for T in terms of C and R. So quite straightforward there. So it's telling you that he buys, so for each pen that costs 24 cents, he buys a quantity of C lots of them. Okay, so in other words, he buys 24 lots of C's, or C lots of 24 cents. Plus, and he decides to buy 37 cents worth of rulers, R. Yeah. And in the grand total, depending on how many pens you actually bought rulers in real life, adding this up will give you a total amount in the bill of C cents. And that's it. This is literally all they want you to do. Just in case to be safe in the exam, depending on how the formula is asked, it tells you the right formula for T. So we should always begin with T first, equals, and then anything that includes C and R. So 24C and 37R. So 24C and 37R. And that's it. We just wrap up from there. Let's go. So number 2. A bus leaves Dubai Airport and travels to Abu Dhabi. The bus travels a distance of 165 kilometers at an average speed of 50 kilometers per hour. So it tells you straight off the bat there's a distance of 165 and a average speed of 50 kilometers per hour. So we're working in kilometers per hour. So hit kilometers and kilometers per hour. Now, of course, you're probably guessing when you find time. So work at the time taken by the bus to travel from Dubai Airport to Abu Dhabi. Cool. Give you answers in hours and minutes. So the general equation for speed, distance, time is always the fact that speed equals distance over time. Since we're trying to find time, we'll make t the subject. So we can say that this can be rearranged to form t equals distance over speed, by multiplying t across both sides and dividing s on both sides. It will appear like this. Since we've got everything we need, we just plug in. So we know that the distance is 165 and the speed is 50. And this will give us the result. So in the calculator, put that in. So 165 over 50. And you should get 3.3 hours. Rounded to 1 dp, yeah? Or it is actually only it was only 2 figures. 3.3 hours. Now, we need to make sense of this, because we need to keep our answers in hours and minutes. So first things first, deducing this one, 3.3, we know that the free part represents the hours, so 3 hours, and we partition the other part, we left with 0.3 hours. Now in your calculator, to convert this to minutes, we need to always multiply this figure by 60, and this will give us our minutes equivalent. So in your calculator, write 0.3 times 60, and you should get 18 minutes. So the result would be 18 minutes. So the total time they took is 3 hours and 18 minutes. Right, number 3, guys. So A, show that 2/7 divided by 4/5 will give us 5/14 without using a calculator. So do not smash this in the calculator, or you get 0. Now to do this, we need to know the general laws of fractions. Firstly, when you divide a fraction, the easiest thing to do is to find its reciprocal, I flip it upside down and switch the divide sign to a times. So this off the bat means that the result is now going to be 2/7, and then we rotate the second fraction and flip the sign into a multiplication sign. So it'll be 5/4. And now we do what we do. Now we just multiply horizontally. You could cross simplify actually before we do that. One unique property of multiplying is that you can look up and down and see if we can find any factors. So 2 and 4 are both in the same times table, so we can divide them both by 2. This result to a 1 and this result to a 2. 5 and 7 are not in the same. 1 and 7 done, 5 and 2 done. And that's it. Now we just multiply horizontally. So we say 1 times 5 will give us a 5. 7 times 2 is 14. And that's it. We've proven it. Easy. If you decided to multiply head on, you would have got 2 times 5, which is 10. And 7 times 4, which is 28. And then you would have to reduce it. be like, hey, this is both, we can both divide these by 2, so it will be 5/14. Either way, this should be fine. Next one, show that these two mixed numbers would equal 1/2. So again, with mixed numbers, the easiest way to do this, honestly, is to partition these completely. Okay, so I would actually firstly revert this to a whole number, to improper fractions. So 3/16 can be written as, well, 3 times 6 is 18, plus 1 will be 19/6. This is one way to quickly convert, is to always multiply the denominator first, so it'll be 3 times 6 mentally, which is 18, meaning there's 18/6, added to the 1 you get 19. Likewise, the second term, the quick way to do it is to realize that 1 whole means 3/3, or 1 times 3 is 3, plus 2 is 5, so it's 5/3. Now, when you add or subtract fractions, we need to make sure they have common denominators, meaning look at 6, look at 3, we can quickly increase the thirds into a 6 by multiplying the second fraction up and down by 2. Up and down, yeah? So this means now we got 19/6 minus 10/6, because these are equivalent. And now we can subtract. 19 take away 10 is 9/6. Simplifying this one, we're going to get, dividing by 3, because they're the 3 times table, we should get 3/2. And now we can just realize, hey, how do we change this into a mix? We can say, firstly, how many times does 2 go into 3? Well, it goes into exactly 1 whole, or 1 remainder, so it'll be 1/2. Remember, the fraction always says, the denominator always stays the same, but this top half represents the remainder of how many times it went into the 3. Okay guys, here we go, number 4. So now we're given an accurate scale drawing which shows the positions of 2 trees, B and C, in this field. Now, when it uses the word accurate, it's most likely referring to the fact that we need to use a compass, ruler, and protractor to make this perfectly accurate, okay? Now, according to this, the scale of the drawing represents 1 centimeter on the map, which is equivalent to 20 meters in real life. So moving 1 centimeter across means if we're going to map this in real life, it will be 20 meters in the real world. A third tree D is also located on this field, where D is 110 meters from B, so it could be in a radius of 110 meters around B, so somewhere 110 meters around it, probably in this sector, and on a bearing of 220 degrees from C. So when it comes to bearing, we always find the angle around the north line, clockwise motion. So 220 degrees will firstly be 190, another 180, and extra 40 degrees after 180. So it will be somewhere around here. Okay, and somewhere on this dotted line until it intersects with the 110 meters. So find this position D, mark this point with X, and label it D. So unfortunately, for these kind of exercises, I won't be able to use a compass, but I can always give an idea of how it could be done. So the key idea is to, for the first part, firstly, the D is 110 meters from B. We need to pinpoint the radius. So if we put a little mark, if you had a compass, put your pin over here and make sure you measure the equivalent of 110 meters centimeters. In this case, because 1 centimeter is 20, we could find the factor, which is dividing 110 by 20, which will give us 5.5. So 110 meters over 20 will give us 5.5. So this is exactly the centimeters required on the ruler. 110 meters is 5.5 centimeters. So on your compass, I want you to actually measure with a ruler the distance from the pin to the pencil and stretch it by 5.5 centimeters. So the pin would be like here, and then the compass pencil would be somewhere here, for example, and then you just rotate it. So I'm not too sure this will be accurate, but in this case, I'm guessing it will be somewhere around here. So when you spin the compass, it will look something like this. And this all has a distance of 5.5 centimeters, yeah? If I did this on paper, it would have been so much easier. Now, as for the bearings, remember, you just rotate it around the pin B. So smash the pin on B and just rotate the pencil around. And then make sure you double check a ruler that everything's 5.5 centimeters around. Now, as for the bearing of 220, we get a protractor and we just got to measure accurately. So we can obviously just realize that one right angle would give us exactly 90 degrees. A straight line will give us 180 or an extra 90. So far up to here is 180 degrees. Now we need to get an extra 40 more to make 220. So on your compass, on your protractor, pin it over here and try and pin it upside down and try and get 40 degrees off it. So 40 should be something like here, okay? And then just keep drawing, keep extending the line. Again, I think my scale is wrong, but this is how it should be. Yeah? So all the way around would be 220 degrees. So all of this is 220 degrees. And I'm guessing the true radius is something like this. Again, I don't know how big 5.5 is because this is on a computer. But assuming it's something like this, I'm guessing it is like this actually. This should be 5.5 then, yeah? Centimeters from B, and then it should intersect somewhere around here. So this should be your D, somewhere around here. When the solutions come out, try and match it, see if you get the same result. Like I said, it's quite difficult to do a real scale on this, but otherwise it's actually a very easy question. Anyway, hope this helps. Let's move on. Alright, number 5. So a circle has a diameter of 18 centimeters. Okay, work out the circumference of the circle and give your answer to the 3 same figures. Okay, this is very easy. First things first, we need to know that the formula for circumference circle, which is always 2 pi r, or even 2 d times pi. But I prefer the first formula. So let me get my pen. So d times pi. D is the diameter, r is the radius. Since we're given a diameter of 18, we could just put in a calculus. It would just be 18 times pi. So the solution would just be 18 pi. And then put whatever this gives you in a calculator, you should just round it up. So this is actually very easy, 2 marks. So to 3 same figures, we just record the first 3 digits. So it'll be 56.5 centimeters. Sometimes we might need to round the final digit, depending on the 4th digit. Because the 4th digit in the calculator is a 4, it's going to round down anyway. So this will be our final result. Wow, so easy. Alright, number 6. So we're given a shape and it looks like a transformation type. So rotate the shape 90 degrees clockwise about the point -2, 1. Ooh, okay, so I actually put this on a PowerPoint just to make it easier. So here's question 6. So rotate shape 90 degrees clockwise. For this kind of question, first things first, always pinpoint the marking. So it's going to be here. So -2, -1 should be there. Okay, so this is where we're going to mark it. This means this is the point where we're going to rotate the entire diagram. The way I do this is I just perfectly mark everything. Okay, so let me move this across. So I calculated the distance mentally. So I would say we want to make a perfect 90 degrees clockwise. So I will take a straight line horizontal to this and mark it downwards. And I realized to make 90 degrees, I need a 90 degrees angle. So 3 blocks down, it means 3 blocks across, meaning this position here is now there. So if I do something else now, if I start from this corner and move it into this point, I want to make a perfect 90 degrees angle, meaning I would just twist this paper around. It's a bit tricky here. If you twist it around, you can make a perfect sketch. Well, it's actually difficult on this one. But the key idea is to twist your paper and force a 90 degree angle, and it should look a bit like this. This would be your new 90 degrees. I'll change the color of the pen as well, yeah? So this means that this is here and this is here. So if we sketch across, we've got 3 blocks across, so it should be something like this. This corner should match this corner. Okay, now what we're going to do, we're going to try and do this corner. So again, you just take one corner here and one corner there. Do the same idea, so draw a dotted line and try and make a perfect 90 degrees representation. And if you do so, you should realize that this will stretch on to over here. Okay, this is a perfect 90 degrees. So connect these two, and then you can kind of have you can kind of guesstimate. Since this line is parallel to this line, we can just extend this final line by 3 blocks. And then you just finally connect them. It's kind of hard to do on this. And that's it. This would be the new shape, exactly 90 degrees. So remember, just draw straight lines, do loads of 90 degree angles, and just rotate. This is one way to do it, but there's of course many ways to do these questions. Anyway, let's get back into the question, into the paper. Okay, number 7. Ooh, probability. So these ones are honestly so easy. So what do we have? So there are only white counters, blue counters, and red counters in the bag. So you always get the typical 3-color questions, yeah? Okay, so mark it down. Charlie takes at random a counter from the bag as usual. The probability that it takes a red counter is 1/12. The probability that it takes a white counter is 3 times the probability that it takes a blue counter. Work out the probability that Charlie takes a blue counter. Okay, what I do is just make a little mini table and just mark our results. So here's the probability, and here is the event. Let's call the event X. Let's call this X, and the probability of getting that event. So probability of getting white, blue, and red. And of course, we know that the total in the end should obviously add up to 1. So probability of getting red we know is 1/12. We also know that probability that of getting a white is 3 times probability it takes a blue. So the blue was, I don't know, let's call it Y. Probability of getting white to be 3 times that value, 3Y. Now, now the smart thing to realize is that the only way to solve this is to realize that the sum of this probability must equal to 1. So this is actually an equation in disguise. So it's going to be 3y plus 1/12 is 1. So summing up these three should get 4y plus 1/12 equals 1. Now you just solve it. So in your calculator, subtract 1/12 from 1. So you got 4y equals 11/12. And then dividing it by 4, let me just see, 11/12 divided by 4, you should get 11/48. Oof. Yep, not something you can think of, but yeah. So this will be blue because blue represents y. So the probability of taking blue is 11/48. Okay, the method is easy. The probability is a bit ugly, but quite straightforward. Just make sure that the total probability always adds up to 1. Number 8, guys. So in India, 62 million mobile phones were sold between these two dates. And if you look carefully, this is actually an exact 3-month period. Okay, so let's just keep that in mind. So 3-month period here. Now, 14.5% fewer mobile phones were sold between this period, which is also a 3-month period. So actually, we're measuring from the same time period, meaning we don't need to worry about the change in time frames. If we did, then might need to adjust our formula. Now work out the number of mobile phones sold in India from the 1st of January 2015 to the 31st of March 2015, so the second line. So the way this works, I always use this cool formula. It's always the original value times the multiplier, which is 1 plus or minus the rate, which equals the new value. If there were different time periods involved, then I'll adjust it using this power n, which represents the number of periods or years or months, etc., depending on how the question is phrased. We don't need it because it's the same period. Now, this means, how does this work? So first things first, the original value is would be 62 million because this would be our opening point. And we know firstly that the rate is that there's a decrease in rate because this is fewer mobile phones. So R would be negative, so it would be 1 minus 14.5%. And that's it. Now all we do literally is just smash this in the calculator and see what we get. And remember, our answer is going to be in millions, so that's why I just wrote 62. Now doing this, what do we get? So we get 1 minus 14.5%, and I got 53.01 million. That's it. That's all you have to do there. Now, next part. So it tells us the table shows information about the mean number of text messages sent by each adult in the UK between these 2 years, 13 and 14. So it looks like there's been a decrease in the mean average number of texts. Makes sense because now everybody's on WhatsApp. So B, work out the percentage decrease in the mean number of texts sent by each adult. So again, it's the same formula as this one. Since it's a decrease, we know we're going to use minus R. But we're actually trying to find the actual rate, the percentage decrease, because now we know the original value is here. So this would be our original value and this would be the new value. We just need to find out what the rate is using the same formula. So let's do it. So we can say OV times 1 plus or minus some rate must equal a new value. We know that the original value is 1,656 times, and we know there's a decrease, so 1 minus R, and it must equal 1404. Okay, so let's just choose some algebra. So the first thing you want to do is divide 1,656 across. So you're left with 1 minus R equals 1404 over 1656. And then what you could do, you could subtract 1 across. So you're left with minus r equals 1404 over 1656 minus 1. And then put this in a calculator and then divide it by a negative sign. So then you're left with just array. So let's just see what that gives you. So 1404 divided by 1656 minus 1. So I got minus 7046. And this, and because it's negative, they're both negative, you can cross out a negative or just flip them with a positive. And that's it, you can just do that. And this is the same as, so if you press an SD function or type this in the calculator, you should get 0.152, or times that value by 100, and you should get 15.217%. So because we want the 1 dp, it's going to be 15.2%. So that is the decrease. So it's a slightly greater decrease than this one here. Yeah, that's it. Okay, now next bit is that the table gives information about the number of minutes Palina used her mobile phone each day in November. Okay, let's see. So, for example, so she used the phone 3 times on some day in November, and she used between 0 and 10 minutes. Oh, okay. And she used it 16 times, and then between 10 to 20 minutes, and so on. So this means under 10 minutes she used it 3 times, between 10 and 20 she used it 16 times, and so on. So C, work out an estimate for the total number of minutes Paulina used her mobile phone in November. Okay, so this one is quite okay. All you have to do really is just think about an average. So the way we can do this, when we got a range of values, we just take the midpoint. So let's do it. So let's take points between 0 and 10, which is 5. Between these values is 15, 25, 35, and 45. And now to find the total average, we can just multiply the frequency times average number of minutes. So it'll be 3 times 15 will give us a total average of 15. This will give us a total average of 15 times 16, should be 240. 25 times 6 should be, I think it's 150. Yep, 150. Next one is 140, and here's 45. Now let's add them up. So this will be the total number of minutes she used on average, without calculating the mean, yeah? So it'll be 15 plus 240 plus 150 plus 140 and 45. I got 590. Check if you guys got the same result. See if you use the same method as well. If you got something different, let me know, please, yeah? But that's it. The answer should be 590 minutes, assuming my calculation is correct. Okay, number 9, so set theory. All right, this is quite easy. So you're given a set between 1 to 12. A represents a set of even numbers. So in this case, A would technically be every even number, such as 2, 4, 6, all the way up to 12. B represents some random digits. Now, A, list all the members that unites A and B. So union is the unites, meaning every term in A plus every term in B, include with every term in B. So let's have a look what they all have. So A has 2, 4, 6, 8, 12. And B has the same thing, except it's also got a 7 and 11. So everything plus with a 7 and 11. So we have 2, 4, 6, 7, 8, 9, not 9, 10, 11, 12. So this is literally everything in both. Now, is it true that 20 belongs in A? No. Even though it's an even number, because 20 does not belong in the universal set. Remember, the symbol at the top represents the universal set. So if and the way this works, these subsets actually take elements from the universal set. So this is pretty much every number available in the existence that involves A and B. If 20 ain't in there, it will never be in A and B. So you say no, because 20 does not belong in the universal set, and A belongs in the universal set. So 20 does not belong in A. Okay. Hopefully this is clear. So next one, part C. So C is a set such that A and C intersect with nothing, so they have nothing in common. So this means that every element in A does not belong to C, and B and C only has number 7 inside. The set C has 3 members. List the members of one possible set C. So we have to firstly exclude all even numbers, okay? And the fact that 4, 7 doesn't include. We know that 7 is included in the intersection between B and C, but 11 isn't. So that means even numbers are out, and these are out. So this means in the universal set, 2, 4, 6, 8, 10, 12 are gone. 11 is excluded, 7 is used. But this means that we still got a possibility of 1, 3, 5, and 9. Yeah, so any of these digits could potentially be in a set. So we could say, alright, so but C has 3 members. List one possible set of C. So we could say, for example, 1, 3, and 7. Or any of the odd numbers and 7. Okay, finally, so we're back to some easy looking question, and you know what, after set theory I was kind of hoping for something different. Now, let's look at this algebra problems. So A, factorize 25n plus 30n. Thank God, easy. All we have to do is take out the common term between both and what they both have. So they're both in the 5 times table, take it out, and they do not have common letters, so it's fine. So now we just need to reproduce this term. So to make 25, we need to times it by 5, and of course m to make 25m. And to make 30n, we need to multiply 5 by 6, and of course we need an n. Boom, that's it. Now, expanding this one, well, just multiply everything by p, so we should get 2p squared minus 3p. Nothing too hard. C, simplify fully. Well, here, just when you're multiplying terms of powers, you just add up the powers. So this means the top line would be y power 5 times y power 8, meaning 5 plus 8, which is 13. Now over y power 4. Now when you're dividing, well, you subtract. So 13 take away 4 is 9. So it'll be y to the power 9. D, expand and simplify this quadratic. It's a double bracket. Well, here we use a FOIL method. So the way this works, you pick one term x, multiply against other x, then the same term multiply against minus 3. Then you take the second term 7, multiply against x and minus 3. So we should get x times x is x squared, x times minus 3 is minus 3x, 7 times x is 7x, 7 times minus 3 is minus 21. And then tidying this up, collect like terms, minus 3x, 7x become plus 4x, so we should get x squared plus 4x minus 21. Oh, easy. Now, fully factorize this. Ooh, just like part A, we just need to factorize this further with every possible term. Okay, so let's look at numbers first. So we've got 36 and 27. They're both in the 9 times table, so we can whip out 9. They both have at least third power of p, so they got 3 p's at least to the power of 3. And for m, they both have a single m. Now we just need to reproduce it. So to make 36, we need times 9 by 4. To get p cubed, well, we have p cubed, so that checks out. To get m squared, we need an extra m. Now to get 27, we need to multiply 9 by 3. To get p5, we need an additional p squared. And m, well, that checks out. Okay guys, number 11. So here is the trapezium. So we're given a trapezium with some lengths, but we're missing one long horizontal length at the top. And they're telling us to work out the area of this trapezium. So very straightforward. The only issue here is that for the general form of trapezium, we actually need 2 lengths. One horizontal length here and one horizontal length here, so we can work out an average. Fortunately, we can actually still work this out, but we need to do a few additional methods. That is, we need to use Pythagoras' theorem, because we need to actually notice that there is a right angle triangle here with a vertical length of 4. So we can technically work out this little side here, let's call it b, and then we can add it to this length here, which is 13, to find a total length, and then use it to find the average and actually work out the area of the trapezium. So let's have a go. So using a right angle triangle, using the fact that Pythagoras' theorem states that a squared plus b squared c squared, we can now say that 4 squared plus b squared must equal 8.5 squared. This means b squared must be 8.5 squared minus 4 squared. And then resolving this one, so timesing this out, so 8.5 squared minus 4 squared, we should get some result, and then if we square root the answer, you should get a b value of 7.5. So b equals 7.5, which is reasonable actually. So if we replace this b here and take off this 13, we can say that the total vertical length now from here all the way to here is 7.5 plus 13. And that should be 20.5 centimeters. Now we can actually work out the area. So the general formula is actually given on the first page. It's actually the average between the two horizontal lengths, so 13 plus 20.5 over 2, so this is the area, times vertical height of 4. And that's all, guys. So when you do that, you should get some result. So tell me what you guys get. So I'm going to write this down. Plus 12.5 over 2. And I got 67 centimeters squared. And that's it. That's all you do. I mean, just double check the result as usual. See if we get the same thing. I think it's okay. But otherwise, let's move on. And you get 4 marks for that. Right, cumulative frequency graph. Ooh, I love this kind of questions. So what does it say? So it says that the cumulative frequency graph shows gives information about the heights of 80 sunflowers. Okay, so it begins at 0 and it's increasing up to 80. Cool. So use the graph to find an estimate for the number of sunflowers with a height greater than 150. So let me zoom out for a second. So the number of sunflowers is a height greater than 150. So first things first, we need to find 150 on the graph, which is going to be on the x-axis. So mark at 150, which is the central line here. So it should cut off here. And this seems to be in the center from here. Now, how many people is that? So that marks out, so everything seems, so on the vertical axis, it seems to be going up in 1. So this is the cumulative. So this means in this case, all the sunflowers have been accumulated. And this seems to be about, oh my God, what is that exactly? 31, 32, 33, or 34. So it seems to be about 33 and a half, but let's just say it seems to be closer to 33, I think. Because we need an actual integer number. So use the graph to find the number of sunflowers greater than 150. So it's going to be the set greater than 33. So it'll be the remaining people after 33. This includes all of them greater. Now, how many is that? So the way you can do this, if we can say that up to 33, there's a height of at least, let me see. The first 33 go up to 150, meaning the other, let's see, 80 take away 33 will be greater. So 80 minus 33, we should get 47. So this represents 47 of the lot. Okay. Use the graph to find an estimate for the median. Okay, so this just means it'll be the middle sunflower. So if there's 80, the middle sunflower will be the 40th. So just draw a line from 40 all the way across, and it should hit, well, it hits perfectly on this line, and you just draw it vertically down, and it should cut off at here. So there we go. And then that figure is going to be, so let's see, that's 150, 52, 53, so 154. That's it. So the estimate would be 154. That's all you do, guys. Okay, question number 13. Well, so sorry if I sounded a bit tired there, guys. I mean, I was actually starving. I just need to get some food. So now, what does this question want? So it states here that we need to find the lowest common multiple of both 24 and 30. Okay, there's a super easy way, and I use Venn diagrams, guys. I use Venns. But the first thing first, let's break down 24 and 30. So 24 can be reduced to using the prime factor tree of 2 and 12. So keep finding prime factors. 2 and 6, and then 6 goes on to 2 and 3. So 24 can be written as 2 cubed times 3. As for 30, this can be written as, let's see, 3 times 10, so 3 and 10, and then 2 and 5. So it's actually 2 times 3 times 5. Now, the lowest common multiple is actually can be obtained using 2 Venn diagrams like this. So one you can label 24 and 130. The middle term represents the highest common factor of both terms, and every single cell, the union of these two, of all 3 cells, is the lowest common multiple. So let's see. So we could say instantly that firstly, what do they both have in common? They both have a 2 and they both have a 3. So you can say 2 times 3. But in 24 24 already has a 3 and 1, 2, but it needs 2 squared more. Whereas 30 already has a 2 and 3, but has an additional 5. So the final result is going to be, the lowest common multiple is going to be the product of all 3 cells. So it'll be 2 squared times 2 times 3 times 5. So 2 squared times 2 times 3 is 2 cubed times 3 times 5. And that's it. And this should give us 2 cubed times 3. So give us 24 times 5. Should be 120. That's it. Now, using the same method, so now they're telling us that A is given by these products and B are given by these products. And we need to find the highest common factor of both of these terms. Again, use the Venn diagram A and B. We're just concerned about the middle part. So what they both have in common? Well, they both have a 2. They both have at least 2 lots of 3s, and that's it. So the highest common factor would be 2 times 3 squared, which is 18. Easy. Okay, number 14. Oh wow, okay, this is very easy. So complete the table of values for this equation. If you're using a good scientific calculator, you should be able to get full marks in this, because all you do is plug in values. For example, let's do 1.5 together. To enter this correctly in your calculator, we just want to write everything here. So when x is 1.5, we should have 1.5 plus 90 over 1.5 squared. So let's just do it like that, just to be on the safe side. So 1.4 plus 90 over 1.5 squared. And I got 41.5. So let's keep it to one decimal place, to standard numbers. Avoid doing fractions, yeah? Next one, do the same thing but with 3. So it'd be 90 over 3 squared and 13. Easy. Okay, now they want us to draw this graph for between values of 1 to 5 for x. So pretty much everything we have here. Okay, so just be very careful here. So when x is 1, we should get 91, so about there. When x is 1.5, we should get 63.7. Oh god. So you gotta be very careful of how you plot this. So 63.7. So that's about, what's one? So 1.2, yeah. So 1.24 is here. 63.7. This is gone up in 2, so it should be around here. Next one would be 1.5 with 41.5. So 1.5 is in the middle. 41.5 is about here. So it's 42. Yep. Next one would be 2 with 24.5. So 2 and 24.5. So just above 24, which is here, maybe. Yep. Next one, 2.5 with 16.9. So 2.5 is in the center. 16.9 should be just a couple below 20. So it's 18. It should be around here. 3 with 13, so 3 with 13, so got 10, 12, so in the middle of 12 and 14, so it should be here. Next one, 4 and 9.625, so about 9.6, yeah, so 4, and just below 10, and last one's 5, 8.6, so just above 8, so there's 8's around here, so about there. That's it. So it should be a nice smooth curve. Well, this is going to be the very hard part because I'm doing it on PC. So I'm just going to draw a dotted line. Oh, so hard. So this one, just be very careful how you smooth it out, yeah? Nice. It's a shame you only get 2 marks for this one because it feels it should be worth more. But anyway, this is the kind of curve you're getting. Now, hopefully it's not too much, so only one question more. So use your graph to find an estimate for the solution of half of this equals 15. So if you look very carefully, we know that y represents all of this, and this is the curve for y. This is the y equation, yeah? So what we could do is realize that we could just make this entire equation equal to y. So let's firstly get rid of the half. So divide half across, you should get x, or times everything by 2, you should get x over 90 x squared equals 30, and we can clearly see that that 30 has been replaced by y. So this means that there was a line of y equals 30 intersecting with our curve of y equals x plus 90 over x squared. That's what happens here. When this happens, these two become equal, and you can obviously make it up to rewrite it. So all they want us to do is draw a line of y equals 30 first. So y equals 30 cuts from here, straight line, and it seems to cut around here. And this seems to be equivalent to, if I'm doing it correctly, about 1.4 to 1.3 to 1.4. So, Okay, number 15, guys. So this is another easy one. Right, P is inversely proportional to the square of D. So we just have to rewrite the statement based on this expression. So this means, firstly, that the letter P is inversely proportional. So this statement, we could just let it be this alpha symbol for now, to the square of D, so D squared. Now, if it's inversely proportional, this implies that we got 1 over K. That's the scale factor, it's 1 over K. So this alpha is basically 1 over K. So we can rewrite this now as P equals 1 over K times D squared. Okay, easy. Now find the formula for P in terms of D, given that with the following given values above. In other words, just literally smashing the values for P and D, and then find the value of K, and then literally plug everything back in, plug the value for K, and you're done. So we can say literally when P is 25.6, we can find the value of K, given that D is 1 over 8. So times 1 over 8 squared. Now all you want to do is literally just make K the subject. So what we could do, putting this in the calculator, 1 over 8 squared, divide it across to make 1 over K the subject. So we should have, let's see, 25.6 over 1 over 8 squared. And that should give you, I'm going to keep this decimal, yeah? 1638.4. And this should equal 1 over K. And now to find K, just take the reciprocal. So K is going to equal 1 over this term, which according to the calculator, 1 over that answer should be 5 over 8,192. So as a decimal, nope, it's worse. So K is 5 over, it's really horrible digits, isn't it? 8,192. And therefore, our final solution is going to be P equals, so right, final formula for P in terms of D, so it'll be P equals 1 over K. I could just choose 1 over K actually. So 1 over K is 1638.4 times D squared, D squared. I could have used the K value, and I just realized 1 over K is what they want. Done. Alright guys, number 16. So here we go. So here we're told to try and work out the area of this triangle. Now thankfully this is a standard triangle, and the formula is actually given in the front of the book. So we can say, using the formula in the front of the book, it states that the area is always half AB sine C. Now what is this referring to? This implies that for any regular triangle, we need two given sides, so A and B, with an angle in between, C. And we got it perfectly there. We got A is 10.5, B is 17.6, and the angle is 109. And that's it. Now just go ahead and smash that in the calculator. So we can say, therefore, the area is half times 10.5 times 17.6 sine 109 degrees. Okay, and when you do that, so I'm going to do it right now actually. So 1 over 2 times 10.5, 17.6 sine 109, and I get to three significant figures, 87.4 centimeters squared. Very easy, very straightforward, thank God. Now, as for part B, they're asking us to work out the length of KL. So KL is this long unknown length. So usually for these kind of questions, just give it a name. I'm going to call it Y. And thankfully for these kind of problems, this is easy, because here we need to either use the sine or cosine rule. And the trick is, if we have three lengths and only one angle, we're going to use the cosine rule. So let's have a look. So the technique is to apply the cosine rule. And in the beginning of the book, the cosine rule is given by this, which is a squared equals b squared plus c squared minus 2bc cos a. One thing to know is that we're using the angle A. There's only one angle, which is capital A, and that's reflected to the little a. So we just have to define an angle A. So every time we have a triangle, cross out the letters and relabel it. So the one with the angle, call it capital A, and the one opposite, call it little a. So I'm going to replace the y actually with little a, just for this question. So now what do we have? So we've got little a, and then obviously these two can be B or C. You could choose any one to be B or C. So going back to the formula, a is well defined, so it'll be a squared equals b squared plus c squared, and so on. So here we can say the equation is now a squared equals b squared, so 17.6 squared plus 10.5 squared. 17.6 squared plus 10.5 squared minus 2 times 17.6 times 10.5 cos, and then the angle, if you recall, was 109 degrees. 109 degrees. Yeah, and that's it. Now all you literally do is just smash this in the calculator and, you know, pray to God that you get the right answer. So 17.6 squared plus 10.5 squared minus 2 times 17.6, 10.5 cos 109. Let's just see how I do right, because you know, these are the kind of questions where it's so easy to actually make a mistake. I've done it many times. Okay, so according to this one, when I put in the calculator, my a squared gives me 540.3399, so on, and then square root the answer with 3 significant figures. A is going to be 23.2 centimeters. Okay, I hope I got this right, but anyways, discuss with your friends and see what you get. This is the general formula. It's all about popping it into the calculator correctly. Okay, anyway, let's move on. Number 17. So we're given a curve with a cubic equation, which is 2x cubed minus 9x squared plus 7. And we're told to find the first derivative, i.e. dy over dx. So to do that, it's very easy. You literally just use a power rule. That is, you look at the power, you drop it down, so it'll be 3 times 2, it's just 6, and then x, then subtract the power by 1, you get 2. And the next one, drop the power, so 9 times 2 is 18, minus the power by 1, you get 1, so just x. And if you just have a constant, well, it's 0. And that's it, 6x squared minus 18x. Okay, that's all you do. Now, next question, the point P lies on the curve C. The gradient at point P of the curve is minus 27 over 2. Find the corner of P. Show clear algebraic working. One thing to know about these type of questions is that the gradient always refers to dy over dx for these sort of questions. Why? Because dy dx is known as the gradient equation, or an expression for the gradient. So we can instantly say that since they gave us a value at point P, the gradient at this point was minus 27 over 2. This means dy dx is equal to this value. So let's go ahead and do that right now. So using the value of dy dx, so 6x squared minus 18x, this is equal to minus 27 over 2. Now we just have to go ahead and solve. So first thing I'll do for these problems is just multiply by 2 to clear the fraction. So we're going to have 12x squared minus 36x, and then add 27 across, so plus 27. So now we have a clear quadratic equation. Okay, can we do anything else? Can we simplify this just to make it easier for us? Yes, you can. What I'll do, I'll just divide this now by 3 just to simplify this. So I get 4x squared minus 12x plus 9 equals 0. And I think that's the best you can do. Now from here we have to actually either solve this using the quadratic formula or factorizing. For most people, I would just say use a quadratic formula because it's just less headache and less risk. Now using the general formula, we're given a quadratic formula, so I'm going to go ahead and input it. So it's going to be minus b plus minus the square root of b squared minus 4ac over 2a, where this value is a, b, and c. This means that we got minus b, so it'll be minus 12, so it'll be plus 12, plus minus the square root of minus 12 squared is 144, minus 4 times a, which is 4, times c, which is 9, all over 2 times a, 2 times 4. Right, so double check the working out and see if you get the same result. So here you should get 12 plus square root. Okay, so my first result, when I use the plus value, I get x equals 3 over 2. And now, if I use the negative result, I got Oh yeah, I got 3 over 2. Okay, that makes sense because why the inside here becomes 0. Actually, if you put this in the calculator, you get 0 for the third part. So it's just 12 over 2 times 4, which is 3 over 2. Find the coordinates of P. So for this case, what do we have here now? So since you got everything you actually need, since you got the x value, now we just need to find the y value. Sorry guys, I do sound a bit tired because I've just been going through this non-stop. So you just literally plug in x value into the original y equation up here. And let's do it. I'm gonna do it up here actually. So when x equals 3 over 2, therefore y equals, so plug into the calculator. So just in case, if you find this uncomfortable, use 1.5. You can check that on your calculator. So it'll be 2 times 1.5 cubed minus 9 times 1.5 squared plus 7. Okay, let's see. 2 times 1.5 cubed minus 9 times 1.5 squared plus 7. And you should get minus 13 over 2. So that's the final coordinate. So it'll be 3 over 2 with minus 13 over 2. Nice. Okay, here we go. Number 18. So, vectors. So A, C, and D are points such that A to C is given by this vector and D to C is given by that vector. Now, find D to A as a column vector. Well, best way to do is to really just see this graphically, what's happening. So you can say if you're going from A to C, so let's call this A and C, they're traveling by this quantity, 3 minus A. Actually, we should make it more clear. We should make it go downwards because it's going 3 across, down 8. Okay. Now, if you're going from D to C, you're going 5 across and 6 up. So probably D is over here. So you're going 5 across and 6. 5 across, 6 up. And this is going 3 across and 8 down. Now, find D to A. So you're going from D to A. So to do that, you can clearly see that we need to go through C. We're going to go from D to C first, then C to A. So we need to go backwards. So we can say D to A is going to be 5 to 6 minus 3 to minus 8. Because when you go backwards, it's negative. So 5 take away 3 is 2. 6 minus 8 will give us 14. So 2, 14. Okay, next question, guys. So given that the position vector of D is 2, 5, so this is the exact coordinate, 2 to 5, 2, 5, and E is the point such that going from D to E is basically going through A to C twice over. Find the coordinates of E. Okay, I would like to make this look a lot easier than it should be. First things first, when we want to find another point, let's just give it a name, yeah? Let's just say straight away that let E be represented by the coordinate x and y. Now, if we're saying we're going from D to E, this means we're going from E minus D. That's what we usually say, E minus D. This means that for E we know is xy and D is 2, 5. So this means the distance traveled would be x minus 2 and y minus 5. Because x minus 2 is this, y minus 5 is that. And now we can also say that D represents 2 times the AC, which we know what AC is 3 minus 8. So we can say now, therefore, using the above equation, D equals 2 times AC, we can say that x minus 2 and y minus 5 must equal 2 times 3 minus 8 for AC. So 3 minus 8. I recommend you guys pause this video and definitely go over this step by step, okay? The key idea is to find the exact coordinates of x, y so we can find a value for E. So let's have a go. So multiplying this by 2, so we should get basically 6 and negative 16. Okay, so that's what x minus 2 equals. So we can say straight away that x minus 2 must be 6 and y minus 5 must be equal to minus 16. Now this is just simple algebra. So we add, so for the first one, just add 2 across, so it says that x equals 8, and add 5 across, so y equals minus 11. So it's 8 and negative 11. Done. Cool, man. Moving on. Okay, probability, so easy. So Mary and Naveed play 2 games of table tennis against each other. For each game they play, the probability that Mary wins is 0.32. So you've probably seen this many times already, but hey, let's do it. So if Mary wins is 0.32, that means it's 0.32. There is no difference between each game. It's always a fixed win. She doesn't suddenly get better in the next game. Okay, that means if it's 0.32, that means the probability that Naveed win would be the remaining, so it'll be 1 minus 0.32, which is actually 68%, so 0.68. So go ahead and put that everywhere, guys, yeah? And you get 2 marks for this, so this is easy 2 marks. Now, work out the probability that Mary wins exactly 1 game of table tennis. So to win exactly 1 game, we're looking at like this. So let's let Mary win be the first game, yeah? So Mary wins the first game and then loses the second, yeah? Or this can happen if Mary loses the first game and then wins the second. So we have to kind of literally put every single option out there. So for Mary to win the first game, it will be 0.32. And for her to lose the second game, it will be 0.68. Now, if Mary loses the first game, again, it's 0.68, and she wins the second game, 32. So now all you want to do is work out these probabilities and then add them up as a total. So in your calculator, write them both out, so 0.32 times 0.68, and you should get 0.2176 for both. So therefore, adding them both, and the probability that Mary wins at least 1 game, the total probability will be 0.4352. Easy. All right, here we go. Next part, guys. So in a fridge, there are only 3 bottles of water, 5 bottles of orange juice, and 2 bottles of cola. Okay, so I'm just going to guess and assume that they won't add them up. So there's a total of 10 bottles in the fridge. Okay, let's stick with that for now. So after their games of table tennis, Mary takes at random a bottle from the fridge, and then Naveed takes at random a bottle from the fridge, right? So far this is independent from the games, as far as I know. Work out the probability that Mary and Naveed both take a bottle of the same type of drink. All right, so one thing to know, when Mary takes a bottle, it's gone. So that means there'll be 9 bottles left. So Naveed will take one of the remaining 9 bottles. So in order to get the same type of drink, here is the probabilities. So remember, Mary first, Naveed second. So if Mary takes it first, so suppose Mary takes water first, we need to find probability that Naveed takes water next. So the other common probabilities would be orange first and orange again, or cola first and cola again. So probability getting water first would be 3 out of 10, meaning there's now 2 waters left out of 9 bottles. The probability taking orange first would be 5 out of 10, meaning there's 4 now for Naveed. And probably taking cola first is 2 out of 10, and that means there's 1 left for Naveed over 9. And that's it. Now all you do is literally, like the previous question, calculate the probabilities and then total them up. Find the total probability. So very straightforward. So 3 times 2 is 6 over 90. 5 times 4 is 20 over 90. And 2 times 1 is 2 over 90. And if you add them all up, 6 plus 20 plus 2 divided by 90, you should get, 28 over 90, which is the same as 14 out of 45. Doesn't matter which one you use. I think leaving it unsimplified should be fine, but why not? Just simplify it. Let's move on. Okay, just looking at this carefully. So number 20. So simplify the given expression. The cool thing about a calculator test is that you can actually smash this in your calculator, because they won't know. So what I would do, I would isolate everything just for the sake of it, yeah? So to make life easy, put the numbers on one side and the layers separately. So I'm going to have 125 over 27, all to the negative 2/3, and then E12 f to the power 3, all to the same power. So we're doing it separately, yeah? So you can just literally smash this in your calculator. You could do it separately, but what is the point? You're given a calculator, right? And if you, in doing so, you should get 9 over 25. Okay. For those who really want to know what happened, because you got a negative sign, you take the reciprocal first, so it'll be 27 over 125. And then you find the third root, and then you square it. So reciprocal, third root, squaring. Now for this one, same thing applies, yeah? So take the reciprocal, so it's going to be, firstly, f to the power 3 over e12. Now, find the third root. So now, oh, actually there's a faster way. Now you can just, thanks to the powers, you can just multiply the powers. So it'll be 3 times 2/3 and 12 times 2/3. So this will give us, so 3 times 2/3 will give us 6/3 or 2. E to the power, so 12 times 2/3, so just put in a calculator, 12 times 2/3, and you should get 8. So it'll be e to the power 8. So the final result, if you stick them together, will be 9f squared over 25 e to the power 8. Easy. Okay, part B, guys. Now we got, what do we have here? So it says 2 to the power half times 2 to the power n over 3 must equal this right side. Express x in terms of n. Ooh. First things first, this is another popular question. The way this works is that they're pretty much expressing the 2's as either powers and 4 and 8 as powers of 2 as well. So the first thing you want to observe is look at the 8 and 4. We need to recognize that everything must be in terms of 2, because you can only solve this if everything has the same base, i.e. 2. So looking at 8, we can realize that 8 can be written as 2 to the power 3, and 4 is the same as 2 squared. This means that 8 to the power x is literally 2 to the power 3x, and 4 to the power n is literally 2 to the power 2n. Now, another thing to note is that, thankfully, because they're all 2's now, the way this works, if you're multiplying terms, you can add the powers. If you're dividing terms, you can subtract the powers. So 2 to the power half times 2 to the power n over 3, this is going to give us 2 to the power half plus n over 3. On the right side, if you're dividing, you subtract. So we subtract these two. So 2 to the power 3x and 2 to the power 2n, we subtract them. So we can have 2 to the power 3x minus 2n. Now, almost done here, guys. So this is telling us that these two are equivalent, and because they both got the same base, this means the powers are equivalent. So we can instantly ignore the base and say now half plus n over 3 must equal 3x minus 2n. Right. First, as usual, to make your life easy, let's go ahead and clear the fractions, yeah? So let's go multiply everything by 2 and then 3. So multiplying everything by 2, you're going to get 1 plus 2n over 3 equals 6x minus 4n, so times by 2. Now multiply everything by 3, you should get 3 plus 2n equals 18x minus 12n. Now, all you do is collect like terms and make x a subject. So what I'm going to do, I'm going to plus 12n across, and then we're going to have 3 plus 14n equals 18x. And lastly, divide everything by 18. So we're going to have finally x equals 3 plus 14n over 18. Voila. That's the end. So if you guys been following, seriously give yourself a pat on the back. You did great. And yeah, let's move on to the next bit. Actually, do we need to simplify anything? Nah, I think this is it for the question. And it's worth it because it's worth a lot of marks. This one, I really recommend you take your time and follow the steps carefully. There is a faster way. I could have just plus 2n across and put, for example, 2 plus 1/3 in the calculator and then divide by 3. But I think for most people, it's easier if we just, tidy this up step by step. So that's it. All right, number 21. Let's do this. So the diagram shows a solid cone. So far they gave us the curved length, so the diagonal curved length, and we also know the diameter of 6.8. So yep, that's what they say. So the cone has a diameter of 6.8 correct to 1 dp. The cone has a slant height of 9.2 correct to 1 dp. Now when they say this correct to 1 dp, what they mean is that the original figure had either 2 or more decimal places. We're going to go ahead and assume 2 because I can clearly see that this is a lower upper bound question as stated here. So this means that the diameter d, so we can say the diameter here is pretty much 6.75 or 6.85, so lower or upper bound, whereas the slant height, let's call it L because that's what they say in the back, is going to be so plus, so round this downwards would be 9.15 or 9.25. Now what do we need to do anyway? So the total surface area of the cone is k pi. So they found the surface area. Work out the lower bound for the value of k. Show you're working out clearly. Alright, this is straightforward. So all you need to really do is firstly find an expression for this equation, okay? Let's do it. So total surface area for this. So firstly, what is the total surface area? Well, if we go back to the beginning of the book, oops, well, you can see my working out is cleared. Well, here is the equation for curved surface area. So the curved surface area part, so just the cone part, not the circle bit, because the circle we know straight away is pi r squared. The curved surface area part is pi rl. So naturally, we don't actually need a height. We got a radius by halving the diameter, and from there we can pretty much calculate everything. So yeah, let's go back for a bit. Let's go back to the equation. So where is it? So using the formula above, so this means this is pi rl and pi r squared, and adding these two will give us k pi. Right. Let's do this. So total surface area. We can say the total surface area is going to be k pi equal pi rl plus pi r squared. So firstly, the radius will be half of 6.8, so it'll be 3.4. And because we're using the half a diameter, so we can say radius is diameter over 2. And we want the lower bound of it, because we want to find the ultimate lower bound. Okay, so this means it's going to be 6.75 over 2. So the formula will be pi times 6.75 over 2. And the length is going to be, let's see, 9.2. So it'll be 9.15, because that's the smaller part. Plus pi times r squared. So again, half of this one, so 3.4. So it'll be it'll be half of 6.8 or half of 6.75 squared. Why? Because we need to find half the diameter. And that's it. Now, that's all you have to do. So, and the things with these kind of equations is that you can now cancel all the pi's, because there's pi's everywhere. So you're left with k equals 6.75 over 2 times 9.15 plus the remainder. And that's it. Just put that in your calculator and just see what you lot get. So we should get 6.75 over 2 times 9.15. Man, I got a really bad cough today. 2 squared. Yeah. And I mean, correct me if I'm wrong, but I got about k being oops. Hold on. So I got k to be about 42.3. Yeah, 42.3. So no centimeters is a scale factor. Yeah, so 42.3. And that's it, guys. I think that is it. Yeah, nothing else to do here. So once you do that, you're pretty much done with this question. So again, just review the surface area properties and let me know how you guys do. And here we go, the final question of the paper. Thank God. So if I sounded tired in the last question, it's only because I'm doing cones, yeah? Usually I don't get that tired. I try not to be, I just pretend. Anyway, let's have a go solve this. Very beautiful. So the way to do this is firstly let y equal the first equation, plug into the second equation, and then expand and solve. Now let's do it. So to make my life easy, I'm going to let y be the subject like I said here by subtracting 2x. So it'd be 3 minus 2x. Done. Now I'm going to put this one and replace it into here. Okay. So it means now that the equation is x squared plus bracket 3 minus 2x all squared equals 18. Now all you do is expand this. So this one is quite straightforward. There's two brackets, and using the usual quadratic method, you should have 3 times 3 is 9, minus 3 times negative 2x, so that's minus 6x. Another minus 6x is minus 12x plus 4x squared, and all equals 18. So I just went ahead and did it quickly because at this stage I think it's quite okay for everyone. Now just collect like terms and rearrange into the natural quadratic form, which is like this, all set to 0. Okay, this is what it wants you to do. Doing that, so we've got 4x squared plus x squared is 5x squared minus 12x. Subtracting 18 across, so 9 minus 18 is negative 9. Alright, almost done, guys. Almost done. We could use a formula or we can factorize it, but I think factorizing, is it possible? Yeah, I think it's possible. Let's have a go. So first things first, I'm going to put 5x here and x there. So you can try a number of ways. Factorizing, completing squares, all up to you really. So we need to firstly make two numbers that multiply to make 9. That is, the pairs are 3 and 3 or 1 and 9. Now the key idea, and I'm going to change the color of the pen, is that we need to multiply one of these values by 5 and then plus or minus the new product with the original to see if we get 12. So let's go ahead and multiply the 3 by 5. So now we have 15 and 3. Can we make 12? Yes, because 15 take away 3 is 12. So to make 15, I just stick a 3 there, because 5 times 3 is 15. And I'll put a minus sign, because we've got minus 15x. And then if we plus it by 3, we get negative 12. And that's it. I think that's it. So actually this was easy because they're both 3's. And that's quite lucky. So now, therefore, we're going to have 5x equals minus 3, or x equals minus 3 over 5, and x equals plus 3. Ooh, almost done. So now at this stage, what do? So do you remember earlier we had the y expression? And yeah, so now all we do is plug everything back into here using this lovely equation. So you can say now, using y equals 3 minus 2x, when x equals 3, so plug into the calculus, so 3 minus 2 times 3, you guys should get minus 3. So that's the first pair, is 3 minus 3. And then when x equals minus 3 over 5, y equals, so plug in minus 3 over 5 for here. So it'll be 3 minus 2 times minus 3 over 5. And you should get 21 over 5. And that is it, my friends. This is the final question. Well, thank you for watching, guys. I appreciate if you guys stayed all the way here. And I hope this was it. Yep, final question. And well, just let me know if anything wasn't explained properly. I would like feedback in the discussion in the comments below, and I'd like to really know your thoughts on this paper and how you think. Personally, I think this paper was definitely more harder than usual. I mean, that's just me. Especially question 20, because 20 can give a lot of headaches. It's a standard idea, but God, they're using very horrible expressions. But overall, I can tell that you just need to really take your time. This probability is quite easy, thank God. This one was a bit different to the norm, so definitely review this one here. Vectors is a particular case. And yeah. Anyways, guys, I hope you enjoyed this video, and I shall see you next time. Ciao.